So let's start with a blue pen, and let's start with a function that's defined as a power series, and I've got it as summation from 1 to infinity of x to the n over n. And of course, if we plug in 1 for n, you're going to get x, and if you plug in 2, you'll get x squared over 2. Plug in 3, you get x cubed over 3. You guys saw this on your quiz, by the way. Just not this exact question. And so what I want to show you is that you can get an expression for f prime of x actually very simply. My expression for f prime of x is going to be summation, and let's look at our power series here. The way we take the derivative with respect to x is all we do is we take a look at the exponent that's on the x when we bring it down in front, right? And then we subtract 1 off of that exponent. So what happens here is those n's cancel, and we get this summation of x to the n minus 1, going from 1 to infinity. And let's take a look at that expansion. If we plug in 1 for n, we're going to get x to the 0, which is 0. I'm sorry, which is x to 0, which is 1. If we plug in 2 for n, we're going to get, well, just x. And then if we plug in 3 for n, we're going to get x squared, and then x cubed, and blah, blah, blah. Now, another way to have found this is to take a look at the expansion instead of the general term and just differentiate that term by term. So instead of doing this on the series here in the sigma notation, I could have just, well, taken the derivative of x. What's the derivative of x? It's 1. And then the derivative of x squared over 2, the 2 come down and cancels, and you're just left with x. And you can see how these are just the derivative term by term of that first one. So there's really two ways that you can take the derivative of a series. Let's take a look at the integral of f of x. So that's going to be the integral of x to the n over n summation from 1 to infinity. And what we can do here is take a look at our exponent on our x, and we can just add 1 to that and divide by that. And that's going to give me n times n plus 1. And I've got this summation here. And I also have in this little plus c thingy. Don't forget, whenever you integrate an indefinite integral, you've got to put a plus c there. So let's take a look at how we could have done that with the term-by-term expansion. The integral of f of x could also have been done this way. I could integrate x plus x squared over 2 plus x cubed over 3 plus dot, dot, dot. And that would give me, if I integrate x, I get 1/2 x squared. And if I integrate x squared over 2, I get x cubed over 3 times 2. I'm not going to simplify that yet. And then if I integrate x cubed over 3, I get x to the 4th over 4 times 3. And you can see that's what would happen if you actually plugged in your 1 for your n. You get x squared over 1 times 2, which is right there. And if you plugged in a 2, you get x cubed over 2 times 3, and you would get this expansion. So you can integrate from the general term, or you can also just integrate piece by piece. Okay, let's go take a look at a pretty cool example of this. Let's consider the power series from 0 to infinity of -1 to the n times x to the 2n plus 1 over 2n plus 1 factorial. And of course, if we write this out, this is, if you plug in 0 for n, we get x over, well, 1 factorial is just 1, and then it's minus, because the next term is negative, x cubed over 3 factorial, and then plus x to the 5th over 5 factorial, and minus x to the 7th over 7 factorial, and on and on and on. Let's just call that function f of x. Let's find f prime of x. Let's do it both ways. Let's take the derivative of the series, don't do anything to that negative 1. So we bring the 2n plus 1 down, and then we subtract 1 from our exponent. 2n plus 1 minus 1 is just x to the 2n. And that's going to give me, if I clean this up, 2n plus 1 over 2n plus 1 factorial leaves me with negative 1 to the n times x to the 2n over, that just simplifies to 2n factorial. So that's one way to find what f prime is. Another way to find f prime of x is just to go through and differentiate these term by term. So the derivative of x is 1. The derivative of x cubed over 3 factorial is x squared. And of course we bring down the 3 over 3 factorial. I'll clean that up in just a minute. And then plus 5x to the 4th over 5 factorial minus 7x to the 6th over 7 factorial plus dot dot dot. Let's clean this up and take a look at it. So it's 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. So what do we have here? Let's see. This original function, do you remember this series right here? You're supposed to remember it. That series in that form or in this form, this represents the function sine of x. And the derivative worked out to be this series right here. And you should know what that series is in this form or that form. It works out to be cosine x. So we just proved with power series that the derivative of sine was cosine. Okay, let's go to another example. Let's show that the summation of x to the n over n factorial, starting from 0 to infinity, is a solution to y prime minus y equals 0. This is called a differential equation. So let's first of all figure out what y is. This is like our f of x. So I'm going to say y is, if you plug in 0, you get 1, and then we plug in 1 for x, and plus x squared over 2 factorial, plus x cubed over 3 factorial, and dot, dot, dot. Well, let's find y prime. Y prime is, we can just bring the n down, and if we're going to take the derivative of this term by term, this first term is going to go away. So I'm going to start at 1 and not at 0, because if I plug in a 0, I'm going to get x to the negative 1, and that just doesn't make sense. So let's plug in 1 for x, and I'm sorry, 1 for n, and I get x to the 0, which is just 1, times 1 over 1, so I just get 1. And if I plug in 2, I get this, my next term and stuff like that, and that's going to be x to the first over 2, 2 factorial, but then I'm going to have a 2 there. It's going to cancel it. And then if I plug in a 3, I'm going to get x squared over 3 factorial, but then that 3 is going to cancel, and I'm going to get x squared over 2 factorial. Now, another way to get this is over here I could actually term by term take the derivatives. The derivative of 1 is 0. I'm not even going to write that down. The derivative of x is 1. The derivative of x squared over 2 factorial is 2x over 2 factorial, and those things cancel. And then the derivative of the x cubed is 3x squared over 3 factorial, and that 3 cancels with my 3 factorial and leaves me with a 2 factorial. So let's clean up what we have here. I have y equals, let me scoot back up, 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. And I have y prime is 1 plus x squared over 2 factorial plus x cubed over... What is this magic? This is crazy. I took the derivative of a function and I got the same series. I wonder what that function was. Y prime equaled y? Oh, that's right, because that's the function e to the x. That's our power series for e to the x. So if I were to take y prime and subtract y off from that, all the terms would cancel, and I would get 0. And so I did show that. Okay, you're going to also practice interval of convergence, but I've already shown you that with your functions that represent f prime and that represent the integral. And I will see you guys tomorrow.